Okay, our next presenter is Andrew Coates, or I'm reliably informed Coatesy, from Microsoft. And Andrew is going to tell us all about what's coming up and what's new in Microsoft in the spatial realm. Thank you.
Well, folks, welcome. My name's Andrew Coates. I revel in the title of Developer Evangelist, and which is quite a fun thing to do. Ask me about that at the bar later on, and I'll explain what that's all about. You might just need to press the space bar once there, just to get us started. This is me. I've done a bunch of GIS stuff before, and I've really enjoyed it. I've done some stuff for local government. That's a reticulation network. I've written a chapter of a book for Pat Hole, and I'll talk a bit about this a bit later on. I work at the University of New South Wales, and I work at Microsoft. So, you all know where we've come from in terms of GIS. We've kind of moved along from sort of the early times with topographic maps through to sort of much more analytical. We've moved from sort of 2D into 3D with layers, and now we've started to look into more geographic data being represented in the sort of fly-throughs we've seen. So we've really moved from this concept of being a niche place to a mainstream place. And of course, once you get to mainstream, Microsoft starts to get interested. Because we are all about that 80% rule that we talked about before with whether GIS is mainstream. Really, consumers have started to understand the power of spatial data. We've moved from sort of proprietary map services, things like MapQuest, MapPoint, Google Maps, and now people kind of get what's going on when you talk about spatial data. So Microsoft have kind of come to that party to some extent with some really interesting things. And I like to say this: every app wants to be a database app when it grows up. And being a database person, that's kind of one of my credos. But really, every database app really wants to be a spatial app when it grows up. And that concept is something that we can really help you with in terms of making it available to everybody. Because spatial data don't have to be geographic. This is an interesting study I did with a radiographer called Roger Uren, where we mapped exactly where melanomas were on people and where they drained to in terms of their primary lesions. And we sort of overturned about 100 years worth of conventional wisdom in the medical profession. Again, happy to talk to you about that. I want to take you on a bit of a journey now. Let's talk about 10,000 years ago. You live in a hill, you live in a cave up on the right-hand side here, about 150 metres up, and every day to get water you come down to the stream. So getting water is quite a big expedition. You come all the way down to the stream, and usually don't get chased by too many saber-toothed tigers, but sometimes you do. Let's go forward a little bit further, maybe 4,000 years ago. You live in sub-Saharan Africa. You've dug a well. Your entire village uses this well. You maintain the well yourself. You don't have to go anywhere else for water, but sometimes you have to send a small child down to put rocks back on the side. Most of the time you get the small child back, but fortunately, producing small children is something which is one of your core competencies. Maybe 150 years ago, you live in London. This is Broad Street. There's a pump, and there's an outbreak of typhus or typhoid. The local health people come and take the handle off the pump because someone else is looking after your water. Nowadays, though, it's not a question of whether you're going to get water coming into your house. It's a question of what you're going to do with it. Are you going to put a cappuccino machine in, or maybe you're going to put a hydroponics plant in, whatever it happens to be. All right? We've moved away from the question of how do we get water as to what we do with it. And that's really what's happened with spatial data as well. We can do things like call the MapPoint web service, which is a fairly standard, easy way of calling spatial information from Microsoft. And it's very easy to put together a very straightforward application. You don't need to really know anything about mapping to do this kind of stuff with find and replace. Virtual Earth is another one of those things, a bit like Google Maps, where we've got a lovely JavaScript interface and some quite nice imagery, especially around here, and that's where we happen to be at the moment, which makes it very simple to create really easy mashups. So we've really moved away from this kind of concept of niche into mainstream. So SQL Server 2008 is the next, I guess, evolution of what we're doing with spatial data. We've really started to bring spatial data into the mainstream of SQL Server. And the neat thing about that is that not only do you get the spatial types, but you get all SQL Server's indexing. And so you can ask questions like this quite easily with a very standard T-SQL statement. Select star from roads where roads intersects the geography. Of course, it's a big problem. So bringing something like SQL Server to that and allowing people to ask those questions with the data they happen to, with the database they happen to have is really very important. So we've got two new spatial data types in SQL Server. We've got spatial operations working as methods, and we've got some great indexing, and I'll talk to you about the indexing later. There's details in the slides sort of afterwards if you want to get those, and a nice map control with SQL Server. So the first type is the geodetic type, which is called geography. Strangely enough, it's exposed as actually what they call a common language runtime type, which means you can actually use that same set of operations you'd use in SQL Server in your applications as well that are written in .NET. It's very easy to use. We've got a bunch of transport formats, well-known binary, well-known text. The planar type is called geometry, which is obviously for the square coordinate system as opposed to geodetic. Uses the Open Spatial Consortium simple features for SQL. Very similar interface for geography, so it doesn't matter whether you're doing geodetic or planar. It's very much the same. So So what we're not doing yet is things like raster data, 3D, although you can store a Z and an M value with your points. We're not doing topology, so points are not, we're not doing all of the topology things you get with a full GIS, and we're not doing network models, so you can't do that sort of thing. I'm going to leave you with this quote from Isaac Newton, who I think was probably talking about Hooke, but I like to think he was being a bit more generous than that. If I've seen a little further than others, it's by standing on the shoulders of giants. And that's really what the platform is that you can build on to build that 80% use case using the Microsoft software. Thanks very much.